Hi, and welcome to Module 5. As I mentioned earlier in the previous modules, rarely can one independent variable explain all of the variance in the dependent variable. It's just not realistic for what we know of as reality. There are many different factors that cause an outcome, and since no one variable can explain the variation in those outcomes fully, we want to provide the most realistic models we can, and therefore we use multiple independent variables. In this case, if we think about the election example from the previous modules, and this goes for any outcome we want to explain, you all know there are lots of factors besides whether voters are male versus female or whether they live in rural or urban areas that are important for explaining the outcome of vote share across a state or across a county, or even for individuals. We think age, race, economic trends, general personal opinions, the weather, lots and lots of factors explain different voter outcomes. And we want to try to capture all of those factors for any particular independent or dependent variables and independent variables that go with them that might interest us. For multivariate regression analysis, the equation looks very similar to bivariate regression, and that's because it is. Instead of y equals a plus bx, for multiple independent variables, we add multiple b's and multiple x's. There's still just one y-intercept. So the equation looks as follows. It goes y equals a plus b1 x1 plus b2 x2 plus b3 x3, and so on until we're finished adding independent variables. Regression will then give us a separate slope, or b, for each independent variable. Then when we create our estimates using this equation, we plug in a specific value of x for each independent variable, multiply it by its unique slope, and use that to generate an estimate of our dependent variable. Just like we would with one independent variable, but we're doing more calculations. We're adding more to the equation, and so we're getting a better estimate with any luck, and we're testing more hypotheses at once. So for example, let's say we want to explain the percentage of votes that go to Democrats across the states, across different US states. And we collect data on age, on gender, and on income in these states. So we have one independent variable that's the average age of the voting population, another one that's the percentage of women in the state, and another one that's the median income of the state. This allows us to test three hypotheses about voting behavior. We think that older people vote for Republicans at greater rates than Democrats because we think younger people are generally more liberal, older people are more conservative. That means the regression coefficient, if we're right, should be negative for Democrats. Remember, the percentage of votes for Democrats is our dependent variable. We think as age increases, people get older, the percentage voting for Democrats decreases. So the slope on that variable, the regression coefficient, should be negative if we're right. For women, we think women vote in greater numbers for Democrats than for Republicans. So we think that variable slope should be positive. As a state has more female voters relative to male voters, we think there should be more Democratic votes, at least in our estimate. Finally, for income, we believe that as income increases, votes for Democrats decrease. We think rich people vote Republican at greater rates. And so the slope on that variable would be negative. As income, median income for the state increases, the percentage of votes going to Republicans would decrease. Please continue on to watch me work through this example and generate an estimate in a program called Explain Everything that you'll find through the next link. It's hopefully very straightforward. You're just plugging in numbers for the different values of independent variables, just like you did before, but to generate a more comprehensive estimate that better reflects reality, we hope, in explaining the percentage of votes for Democrats in a state. So I will see you soon in Explain Everything. See you later. Bye-bye.